So let's start the webinar. Just a minute. Hello, dear participants. My name is Serhat Boynukalın. I want to thank you for your attendance today. It's my honor to present you our latest software, Hi-SimTrain. Before we explore today's webinar in depth, I would like to give you a brief info about our agenda. But before starting that, let's mention about the house rules. During the season, the participants' video will be turned off and their microphones will be muted. In case of you want to ask any questions, please use the Q&A feature to ask the panelists. You can write your questions anytime you want, and it will be answered immediately or as soon as possible. So let's start the webinar outline. Initially, I will invite the Professor Söylemez, the CEO of the Hi-Sim Technology, to the stage, and he will share his insightful thoughts with us. Secondly, I will invite to the stage to Dr. Açıkbaş. He is the consultant of the Hi-Sim Technology. He will provide us his valuable perspective and ideas. Following these insightful demonstrations, we will start presenting an informative videos about the data requirements, application usage, the detailed demo for the breaking curve and reporting side. After that, we will carry on a live demo with you. In case of you ask any questions, we are going to answer all of that questions after the demo. When we finish the demo, we will get your questions and actually we will give information about the licensing. Then we plan to finish the presentation. Let us to begin. I extend my warm invitation to Professor Söylemez to share his thoughts and future of expectations of his. The stage is your, Professor, if you are aware.
Thank you, Serhat. Welcome, everybody. So, actually, in this presentation, we will be presenting a newly developed software by our company, Hi-Sim. So I'd like to introduce you Hi-Sim briefly. Actually, we are kind of a small company in Istanbul Technical University, Technopolis area. However, we have a very agile team, and we have been working on especially railway simulations for a quite long time. Although the foundation of the company dates back to 2016, actually we have been working on railway simulations for more than 20 years. So our capabilities include traction power simulation, signaling simulation, and also operational simulations and train movement simulations. And we have several different kinds of software that address such issues. However, in today's talk, we will be focusing on Hi-SimTrain software, which is newly developed by our company. And we will be giving you some details about this software. So I don't want to steal your time, actually. So welcome, everybody. So I'd like to leave stage back to Serhat.
Thank you, Professor. Now I want to invite Dr. Açıkbaş to share his expertise. The stage is yours, Dr. Açıkbaş.
Okay, thank you very much, Serhat. Yeah. First of all, I want to thank everyone who actually reserved some of their precious weekend time and then joined this webinar. I should say welcome, good morning or good afternoon, wherever you are listening this webinar. Okay, so as Turan has mentioned, that actually this company is relatively small, but we are working on most rail systems engineering solutions. We can say that since 2016 officially, but before that also we have done so many simulations in the past with different company names. So, but maybe I should introduce very slightly about the Turan, maybe, and myself. Turan is a full-time professor in Istanbul Technical University. He's a software and control systems engineering, and then he is the founding professor for the rail systems engineering master degree in Istanbul Technical University. And then he is also a committee member in IEEE and also the Shift Rail. Now it's called Europe's Rail. So he's one of the 12 professors. And as for myself, actually, I'm in the industry for the last almost 30 years in the railway system sector. And now we are working as consultant to many different companies through Hi-Sim. And personally, I've been outside of Turkey and maybe around 7-8 years, working always as a general consultant or independent check-in engineer. So I'm always inside the sector and hands-on experience, which is transferred to the Hi-Sim side. And then our software always keep developing. So maybe I should summarize, as Turan suggested and Serhat suggested, what is this Hi-SimTrain? And then what is the difference? As Turan mentioned, okay, we have our admiral ship, what we call in the industry, Hi-SimOx, which is very powerful software, which is certified against the European standard for the accuracy or by independent assessors. But since it's so big, for some activities, it takes time, to be honest. Recently, in like 6-7 months ago, we did a project to Turkish State Railways where Serhat has actually developed an eco-driving algorithm. Of course, if you give a job to smart people, they find an easier way to find and then complete the job in a shorter time. And then he came back to us. I think Hi-SimOx is too big. It's taking a lot of time for us. We think with Emre Hoca, he is also a professor, assistant professor at Istanbul Technical University. We want to develop another different software. And then they actually, in a couple of months, they developed this software. So we want to present this software. Let's make it very clear. This software is, at the moment, is single train simulation software. So what does it do? It actually allows you to model quite accurately your line, alignment data, and train parameters. And it allows you to play with the parameters and you immediately get the results. The beauty of that, you don't need to buy license. This is at the end of the day, will be given software as a service. So you will be able to connect to the server and then quick, easily, you model your line and project, and then you obtain your results. If you like the results, you produce the reports automatically. Let me give you some use case for this software, okay? I see that many of participants are actually within the industry, so they will understand what I'm going to talk. First of all, when you are developing a new line, you need to think about a lot of different alignments or station locations. Also, you will be questioning what type of train I'm going to use, or what should be the maximum speed? If I use 160 or 140, what would matter? How many seconds the travel time will differ? And then, of course, what would be the energy consumption for each options, okay? So by using this type of softwares, you need to do simulations. If you don't use, probably you will end up with wrong assumptions, and fleet size of your project, let's say, is determined in a not really correct way. Also, in this software, Serhat will show it to you that the eco driving using costing algorithm, which is the most effective energy optimization at the market, and then it's proven by scientific research, or there are some signaling companies providing different types of the energy efficiency. They call it train performance parameters, such as they reduce to maximum speed, or they reduce to maximum acceleration or braking things, okay? So all these type of things can be done with this Hi-SimTrain. And then, as I said, this is quite new software with the feedbacks that we get from users, which we will be opening up for trial usage also after a month maybe. And then we will also keep improving this software. I think that's enough, Serhat. Yeah, you can continue.
Thank you very much, Dr. Açıkbaş, for your valuable inputs. Let's start the demonstration. Just a minute. Okay. Now, most of attendees might know that this simulation in this domain requires a data book file, which generally stores all related vehicles and trackside parameters to run the simulations. So we prepared for you the demonstration video to show you the details of this data book file.
Hello, today we will try to introduce the Hi-SimTrain application to you. The Hi-SimTrain application is a specialized program developed for electrification and operation optimization of railway vehicles. Before providing a detailed introduction to this program, it is beneficial to examine the creation of the necessary data sets for the operation of the program. First and foremost, determining the general parameters is crucial. The sampling time of the application, the maximum simulation duration allowed for a single request, the metering precision of the application output, how closely the speed limits will be monitored, standard gravitational force, the starting point of the line, west, the ending point of the line, east, the elevation value of the starting point according to the direction of the line, selecting the direction of the line as west to east or east to west. After selecting the direction of the line, it is beneficial to check the elevation value because this value may vary depending on the direction of the simulation. The next area we need to examine is the section where detailed settings for the lines drawn on the screen graphs are located. In this area, frequent changes are not necessary. In fact, for your convenience, the most optimal color options and details for the vertical and horizontal axes have been set as default. Still, if you wish to make a change, there is a screen where you can modify the RGB values. Not only the RGB values, but also the modification of the texts on the X and Y axes is possible. The next section we need to review is the part containing the train parameters, which include the most crucial parameters. This section includes mechanical, movement, traction, braking, as well as power parameters. In the mechanical section, the structural parameters include information such as the length of the train, the frontal area of the train, and the number of cars and axles in the train. In the mass parameters, it includes the mass of the locomotive, a logic variable indicating whether the adhesion effect will be considered or not, the total mass of the train in the simulation, the empty train mass, the maximum load the train can carry, and the percentage value of the mass rotation factor. Additionally, the train parameters also enable a copy-paste feature that facilitates the easy transfer of train data between two different Hi-SimTrain applications. In the Performance Parameters tab under Movement Variables, it allows inputting the maximum speed, acceleration rate, deceleration rate, and the comfort factor. In the Mass Parameters, there is a field that takes input data dependent on the Davis coefficients AC0, AC1, and AC2. The next input field is where train acceleration and braking parameters are entered. Firstly, The maximum traction force that the train can apply corresponding to speed must be prepared for the program in a tabular form. Following that, similarly, the maximum braking force that can be applied corresponding to speed must be prepared for the program in tabular form. Here, instead of the maximum force that the train can apply corresponding to speed, if provided by the manufacturer, the acceleration value corresponding to speed can also be entered into the program in tabular form. Finally, in this field, the braking deceleration value corresponding to speed can be entered as shown. If there is detailed information regarding the braking deceleration value corresponding to speed, it may be prepared for the application as a table. When looking at the inputs for power values in the train parameters, if the train is selected as electric, voltage value and efficiency data based on the vehicle's speed should be entered for energy calculations. In the case where the vehicle's diesel model is selected, diesel fuel calculation and efficiency data should be entered in a similar manner. The next data entry area is where safe braking models are selected, and the necessary data is entered when required. Firstly, there are three types of braking models. The first one is a local algorithm that approaches speed limits as closely as possible to the vehicle limits without using any braking model. The second model is for CBTC systems, and the third model is for ERTMS systems, defined according to the subset 026 standard. In the braking model defined for CBTC systems, the following parameters need to be entered as a table: runaway time, coasting time, position uncertainty, speed uncertainty ratio, whether the speed will be normalized or not, and the track speed limit along with the gradient acceleration data. In the ERTMS section, there are detailed parameters, each of which affects the output of the application. It can be selected whether the train will follow the warning, service braking, or emergency braking strategy. The train parameters section contains many variables within itself. Similarly, braking parameters and national parameters contain different variables. Each of these should be carefully selected. The next data table is our table containing the speed limits of the line, which are generally determined during the design phase. Here, for each section of the line, the maximum speed at which vehicles can move is given in relation to the distance of the track. The data can be easily transferred into the application using the copy-paste method. It should be noted that this table should only change if the track line is physically modified, which this is not expected in general. Our next table is the track curve data table. In this table, where curves on the track are entered based on radii, if the vehicle is moving on a straight track, a very large curve value is entered to perform calculations. In our next data table, the variation of tunnel coefficient, depending on the meter, is entered into the table. This value can be selected between 1 and 2. When 1 is entered, it means that tunnel effect will not be taken into account. When 2 is entered, it should be known that the tunnel resistance will be considered maximum. Additionally, tunnel data can also be entered in a segmented manner. Our next table is the track beliefs and its location accuracy data table. In ERTMS-based simulations, this data is crucial. It can be ignored in simulations where CBTC or internal braking protocol is considered. Our next table is the table containing station data. In this table, the long name of the station, the short name, the direction of movement, the start, end, and middle points of the station, the minimum travel time, the travel time in full power mode, and the maximum travel time. How long it can go in eco mode are entered as inputs, along with the waiting times at the station. It is not mandatory to enter minimum and maximum travel times, but considering that these times are determined during operational design and are especially used in coasting optimization scenarios within the program, it is beneficial not to leave them blank. Details of how these times are used will be shown when explaining coasting optimization. Our next table is the table containing train driving profiles. In this table, the details of how the train's speed, acceleration rate, deceleration rate, and coasting parameters will be used are determined. The percentage at which speed, acceleration rate, and deceleration rate will be applied, as well as whether coasting mode will be enabled, can be selected. In full eco mode, the speed, acceleration rate, and deceleration rate might be restricted compared to other modes, as shown in the table. This work shows the progress of data book preparation. Thank you for your listening. Hello.
Now we have showed you the necessary data requirements for the application. In case you do not have any questions, we will start presenting you a demo, at the video demonstration how to basically use the application.
Hello, everyone. We will examine the general parameters, train and track data, posting, and assess the all-out and eco performance modes for the entire line. First thing first, let's load a config file created based on the databook file and see all the data on the application. Here are the general parameters, and you might select the direction of the line. This properties for the scope visualizer options. You can select any color that you want that will change related graph color immediately. Also, you might modify the graph axis. The following window shows the train properties. As shown in the databook file, train properties consist of mechanical, movement, traction braking, and power. Also, the train properties might be copied and pasted like we did to send another Hi-SimTrain application. A train force versus speed table or acceleration versus speed table for the traction side is possible. We preferred traction forces versus speed table in this config file. We have an excellent property here to help optimize traction force power usage, which you might like to use in case a train loses one of its engines. For example, in case a train loses one of two engines, we can write here 50% to simulate half the power of the traction force. Also, here is the braking force versus speed table, and here is the deceleration versus speed table. In the power section, you have the option to choose between electrical or diesel power sources. Each option comes with its own set of efficiency tables, allowing you to make an informed decision based on the performance and efficiency metrics provided. The next property is safe braking data, which allows the selection of internal CBTC or ERTMS braking curve algorithms. Here are the CBTC properties and data tables. Speed limits and Geber tables might be modified related to the project. Let's go into detail on the ERTMS parameters. Here are the ERTMS train parameters. Here are ERTMS brake parameters for gamma trains, which consist of multiple parameters and tables. It can be modified by selecting the Edit checkbox. A brake emergency data and a brake service data table are entered in tabular form. In case the edit is finished, don't forget to uncheck the Edit checkbox. Here are ERTMS brake parameters for Laby MDA trains, which consist of multiple parameters and tables. The displayed content is in an organized tabular format. This layout enhances readability and emphasizes the functionality that allows users to effortlessly copy and paste all related data directly into this interface. Here is another ERTMS dataset that is national values, which can be modified easily. It is supported to simulate warning, service brake, or emergency brake algorithms for braking curve calculations. In the case needs of brake inhibition and reduced adhesion properties, it needed to be prepared all related data in tabular form. This was a quick check for ERTMS properties. We will test it in detail, or you might test it on your own too. Let's dive into trackside data by starting with track speed limits. The position versus speed restriction information is clearly organized in a table format. If you have a single line and want to reverse all the data to simulate the reverse side, there is an easy solution for this case. Before I show you that, remember to select the reverse side selection in the general parameters and save it. Now, let's see how easy it is to reverse data. Clicking the Apply the Same Data for the Reverse Direction button will generate the correct data for the reverse side. And this works for all trackside datas. Now, let's see the gradient data. And clicking the Apply the Same Data for the Reverse Direction button, same as before. So, Let's do this operation next to track curve data and tunnel data and balice data, which is only taken into account in ERTMS-based simulations. And lastly, station data can be easily generated for reverse simulation. Next, train driving properties are shown in tabular form, which displays the characteristics of train driving. It can easily define a new driving policy. In this case, you have infinite possibilities. Let's write in test property. You can change the use percentage of speed, acceleration, and deceleration values. As you see, we selected 50% for all parameters. When saved, it will show up at the train driving policy combo box. Now, it is possible to use it in the simulations. In the energy efficiency section, the best parameter is coasting, which we proved with our multiple academic publications. If you do not read them, you should be. There is no one-click solution to reverse all data for this property. However, we have developed an enhanced algorithm to find cost points easily. We will give more info at the coasting optimization side. Let's add a test value to the reverse side of the simulation table to demonstrate manual editing. The value should include the following information: direction, train type, coasting start and end points, coasting start and remotoring speeds, along with a note that will be used in the report to inform the driver about necessary adjustments for optimal performance. So, let's save this and move forward to the next property, which is eco speed limits. It is generally most useful to apply at the end of coasting or when reducing maximum speed. Let's add a sample speed limit that reduces the maximum speed from 120 to 100 kilometers per hour for the entire road in both directions in the eco profiles, effectively enhancing safety and reducing emissions. Remember, these speed limits only apply to eco profiles. To add speed limits to all out, you need to update the track speed data. Let's save this and review the coasting optimization parameters. First, it needs to initiate the data of the station, which will be used to calculate coasting points. Next, to prepare for coasting points, we need to allocate 121 seconds, which the all-out scenario needs at least that time, and then add an extra 10 seconds. Once we determine where the coasting will finish, we can request optimization to find the location. As you can see, the vehicle actually finished coasting at around 34420. Rearranging the coasting end position and then starting the optimization will produce optimum results within a 10-second margin. When optimum coasting points are generated, they can easily be added to the list by clicking the Add to Coasting List button. So, we generated reverse track data and demonstrated how to optimize coasting data. Now let's optimize in the normal direction as well. Let's analyze the data from Station 1 to Station 2 for coasting operation. As mentioned earlier, let's allocate time as all-out mode is needed and some extra margin to calculate the optimum points. As you can see, 3200 is the optimal point to finish coasting. Let's add it to the endpoint and rerun the analysis, which took a total of 173 seconds and resulted in a decrease in energy consumption from 35 to 9 kilowatts per hour. Let's add this to the list of key points and check to ensure it was added successfully. At the top of the list, you can see the most recently added points of coasting points. You also have the option to add a note to support the reporting process. Due to the fact that we have a similar coasting points for that area, let's remove these points. General parameters, train and track parameters, and eco-friendly properties have been addressed. So finally, we are ready to proceed with the simulations. Let's simulate the complete line in all-out mode. As you can see, it was simulated very quickly. Let's simplify the graph by clicking on the relevant labeled text and disabling them from view, and simulate it again. Now let's test it for the eco profile and see what changes. For the complete line, the timing increased around 10%, but power consumption decreased 35%. Full eco mode reduces energy consumption, but it is not as efficient as eco mode, which restricts acceleration values, but leads to too much time consumption. As previously mentioned, the potential for different modes is infinite. The performance will change with different gradient values. You may have the opportunity to find the best one for your project. That's why we offer this application to all types of authorities. Thank you. Hello, everyone.
So you have seen the basic usage of the application. Now, if there is a questions, we can take them. Or we will go too deep into breaking algorithm benchmark.
You can write your questions in the Q&A box, and then we will be seeing and then answering them later on.
Okay, we have a small demonstration. We have passed the big videos, so it remains the small ones. Just a minute.
Hello, everyone. We have news for you. If you want to simulate different braking model algorithms, Hi-SimTrain is for you. It supports CBTC, ERTMS, and an internal braking algorithm. So let's get started on the examination of the application based on this subject. We start with internal braking algorithm. Let's simulate and see the effect of the internal braking algorithm. We opened a mechanical and electrical log window to add results. Firstly, we added speed and power versus location output for internal braking model algorithms to the graphs. Secondly, we simulated the CBTC braking model algorithm and added the results to the graphs. Adding graphs on the same axis will help to visualize performance more easily, ensuring a clearer understanding. So lastly, let's select the ERTMS braking model algorithm from the Safe Braking Strategy tab. The results are here. And add the results to the benchmark scopes. Now we can see and examine the effect of the difference in the braking models. As a result, respectively, ERTMS, CBTC, and internal braking model algorithms consume time between stations 187, 161, and 155 seconds. ERTMS, CBTC, and internal braking model algorithms consume different power based on different braking algorithms. Thank you.
So we have shown the braking algorithm difference in this demo. At the end of this, we are going to show you the reporting side of the application. After that, we will start the live demo. Please do not hesitate to ask your questions. Okay, let's start it.
Hello, everyone. We will examine the reporting process based on CBTC and ERTMS outputs. Let's open the Eco-Driving and Report section. It is possible to choose between all modes and benchmark them with each other based on a safe braking strategy. So let's select the CBTC braking curve algorithm and simulate it to benchmark the output of the complete line for all out and eco profiles. On the reporting side, as a strategy, select all out versus eco profile, and for the stations, choose from 1 to 9th stations, and then start the simulation. Before finalizing the report, if it exists, it is essential to add a logo. Please check and write the report's header, title, and other essential details. Ensure that all information is selected correctly and saved in the parameters. The next step is to generate a report based on the report parameters. Let's wait for a couple of seconds while the report is generated. Here it is. Save it in the relevant path. We will save it alongside the ERTMS report, which was generated earlier, and we will use it to benchmark reports against each other. So, let's bring PDF reports front to benchmark them. Allow us a couple of seconds, please. Here it is. Open the ERTMS and CBTC reports. Let's examine the details of the reports. You can see the ERTMS report's header, title, and other text marks. Here is the documentation history info. Next, the abbreviation list and methodology explanation. After that, the operational summary has been given. It clearly displayed the details of all-out and eco-profile parameters. So, based on these requirements, here is the first station to station simulation result visualized in the graph. So let's examine the CBTC-based algorithms report too. Opening the same part of the reports will help easily visualize the difference between the ERTMS and CBTC-based braking algorithms. Switching between reports to compare the differences. So it is similar to other sections of the report. Let's move on to the report's final part, which summarizes all the profiles. Here are the general results of the report, which shows energy reduction and time consumption. To compare ERTMS and CBTC, ERTMS takes around 1.5 minutes more time for the entire line, while CBTC is 2.5% more efficient than ERTMS. To be fair, coasting points are not optimized for the ERTMS side. In the case of optimization, it might increase energy efficiency. However, drawbacks with timing will continue. Also, coasting and speed limit tables are available in the report. Thank you. Hello, everyone.
So we have finished the video demonstrations. We will start the live demo. I guess we have a question. Simulate multiple track operations. Emre Hocam, if you could answer this one.
Okay, so although this software is mainly developed for single train and single track operations, however, this feature may also be added if requested, because your feedback is very valuable to us.
Okay. We have a couple of questions, but let's answer them after the live demonstration. Now, in case of we do not have any questions further, let's start the live demo. Allow me.
Maybe I should add a little bit more about that question. As we mentioned that actually we have other software which is quite capable of like 100 or 20 different tracks and then switches, track circuits, everything can be used. But as we mentioned, this program intention is slightly different. That's why it's lacking, but it's in our mind that maybe we will be adding at least one more track and allowing the headway analysis like turn back headways, introducing the switches. That's it. But for very extensive operation analysis, we have another solution, to be honest. Okay.
Just a minute. Let me to share my screen. Here the application is. Firstly, let's load the test line here. Let's make a CBTC test. For example, I mentioned it in the video, but I didn't carry out the solution there. For example, you have a train with 2 engines running, and you lost one of the engine. What is going to be at the moment operation? What's going to be happen? Let's find it out. For example, here, one of 2 engine is lost. Let's make it between 2 stations, and then we can carry out the 4 whole stations. Let's disable all of this to see the just speed limit and the train speed and curve. Allow me to open another application. Okay, Let's make it CBTC train. Here is the results. As you see, the difference in timing is around 10 seconds if you lost one of your engines, and the power consumption is reducing, as you see, but the regeneration is a little bit goes down. We can carry this simulation, for example, in ERTMS too. In a long pull-out mode, actually. And here is the results. In ERTMS, as you expected, the timing is consuming more, around 10 seconds at this point too. And the consumption of energy is reduced a little bit. So we can carry, for example, another test case here. For example, in case we the gradient of this simulation here is similar to real life application, but if you want to see the effect of, for example, just single engine reducing, we can select, for example, the gradient of the track as a zero, a flat line, and see the effect here. We need to select second station. And here is the simulation. Just a minute. Let's make it for another application. Let's load the flat line. We carry this into CBTC. What is the trim parameter? 100%. Okay. Let's select CBTC and trim parameter 50% of traction power usage. Let's simulate. As you can see, the timing is increased. Power usage has been lowered a little bit, around 6 kilowatt per hour, and the regenerative energy is a little bit downgraded. So it has too many possibilities here, but it depends on what you need and what you want to do. If you have any questions, which I see a couple of questions here, just a minute. Transmission into the line, send your ERTMS signal.
Okay, maybe I can answer this question.
Yeah.
For now, it is possible to simulate such scenario by just creating different configuration files. So one of the configuration files will be generated for CBTC part of the line. So assume that between station 1 and let's say 5. And another config file will be generated for the ERTMS part. And you can just simulate both of them and combine the results. However, if again requested, we may add such a feature to program, so we can integrate or we may offer to choose which part of the line will be it will be used the CBTC signaling and which part is ERTMS. Then we can get the result and also report depending on that property. So yes, we may add this, but for now, for that version of the program, you can also do this by creating different configuration files.
We have another questions.
Okay, perhaps I can also answer the coming questions. So as Emre said, for the previous question, we can have integrated CBTC and ERTMS systems. That shouldn't be a big problem. For the moment, you need to do this in different files, but in a future work, it's not difficult for us to have them in a combined way. There is a question: does the tool determine which signaling system will be best suited for a new line based on the available information? Again, actually, the tool might help you in such decisions because you can easily examine how the trains will be moving in different signaling systems. Obviously, that's in the decision-making process. There are many parameters, but one of the parameters is obviously the travel times and energy consumption. And as far as these two parameters are concerned, the tool can definitely help you in comparison. So there is another actually question where we have multiple questions. The first one is, does the program include the elevation of the stations? Yes, it does actually. You can give all the elevation information of the track, and it's considered by the program. The second question is about the comparisons made for only one train. Is it possible to do it for more than one train in order, for example, to monitor power supply efficiency and its effect on the whole power consumption, or is it negligible? As Süleyman mentioned earlier, actually this tool is for movement simulation only. So in the simulations, we do not consider the effect of the power system. So we assume that there is enough power. However, we have other tools, especially for power simulation, traction power simulation. And in such tools, we can actually simulate the effect of the whole system, the power consumption, etc. In here. But if you just would like to get a quick result about how the trains will be moving in your system and what would be the power consumption, the tool can give you a quick idea.
May I interrupt here, Hocam? I think the question might be also asking, is it easy to change train parameters? If it is the case, yes, you can change the parameters, track for the transition speeds or base speeds. You can immediately see the effect on the travel time. You can see the effect of such change on the energy consumption. If for you the seconds are so important for your operation planning, then you can try tweaking those parameters a little bit at the beginning of a project, and then you have to define. And then that could be also in the future for us and a potential add-on to define the high-level requirement for the train, and then automatically it will suggest you what would be the track effort to meet such high-level requirements. It's also in our mind, it's quite easy to implement that way as well. But as Turan mentioned, if you are thinking about the regenerative braking and it's taking and giving to other trains, that's another thing. For that, you need to have really, really detailed software such as Hi-SimTrain or some other softwares in the market, which is also need to be validated against European standard 50641. I'm just answering the next question with this, Turan Hocam. Yes, we have the validation from TÜV, both for AC systems and DC systems. It's quite accurate, that software, not this one, okay? This one is only for train movement and then train performance calculations, single train at the moment. But for other detailed analysis for the electrification for AC size or DC traction system, we have Hi-SimTrain You can see it on the internet. It's quite powerful software and it's validated against the European standard for both 25 kilovolt AC system and all voltage levels of the DC system. Okay, sorry. Okay, Turan Hocam, you can
Okay,
continue.
thank you, Süleyman.
Yeah.
I believe the questions have been answered. For modes, we have to give static inputs beforehand. Can we make a program algorithm to try different modes to find out the best energy consumption? Again, actually, we can do this. Serhat is now showing this to you, that you can try different strategies in a dynamic way, and then for each different type of strategy, you can see your results and see the time, the travel time, and also power consumption. So that's one of the powerful sides of the software, actually. The last question is, do we have to give brake force in regards to speed, or is it possible to have profiles for that? Yes, actually, we can provide the brake force versus speed, but this is especially for calculation of dynamic brake force and the regenerative energy calculations. So it's possible. And I believe this question has been answered. And as far as EN 50641 is concerned, Süleyman has already provided the answer. It's not relevant with this software because we are not really dealing with the power system, traction power system. However, as far as validation is concerned, perhaps we should mention that we have compared our results with real data in different projects, and have shown that the results are compatible with real field values. I believe that finishes our last question.
Yeah.
If you have any questions, please do not hesitate to ask again. Serhat, you may continue.
Okay, thank you. So we have demonstrated a couple of possibilities in this application, which it has infinite possibilities. You can change your own. And actually, I want to show the last thing. We have train control simulations, which allows us to use the train actually. That's to show you. For example, I have initiated the train's data into the system, and let's drive here between station 1 and then station 2. Here is the our all-out scenario driving policy here. So, and the speed limits, we can put it here. And if you want to see the track gradients, you can see here, and power curve, but I don't need power curve for now. When you start to train and put and at the maximum level to control input, train starts moving, and as you see, the black line here is simulating the train movement in case of drivers or anyone who want to know how the train moves and how it works. It is useful tool actually. For example, I downgraded the tool. In case you do not use it as it should be, for example, we have a huge service brake here. You see the train's movement. You can put a maximum power here, and you can actually see the power consumption from this value, the traction energy. So anyone who use the full power and the training will see the cost of the what he or she is doing. So in case of you do not have any questions, I will going to give information about the licensing. Yep, let's stop it. It takes too much time. Allow me to share just a minute.
Page down.
Here.
Yes.
Professor, if you want, you can continue to give information about licensing.
Okay, actually, what we plan to do with this software is actually we'd like to have a freemium. We will have actually 4 versions. One is the freemium, and the others are premium for CBTC or ERTMS, and also we have an enterprise version of the software. The freemium is a free, actually, as the name suggests, is a free trial version of the program. There are no much limits actually, but actually you can just try to see what kind of data you can enter into the program with this version. And you can do some simple simulations. However, CBTC or ERTMS signaling rules will not be able to be used with this version. And also, you will not be able to get a report because we consider such issues are more like professional version issues. And there is a time limit of 1 week of usage for the premium version. So if you wish to register for the freemium version, if you wish to get this program, please register through the address given on the page. For the other professional versions of the program, the premium CBTC and premium ERTMS, the difference between them is that in one of them you can use CBTC rules, and in the other you can use ERTMS rules only. In enterprise, you can use both versions at the same time. Actually, the pricing will be on project based. So depending on the length of your line and the number of stations, we will be giving you a price, the minimum usage, and also the time period you wish to use the program. The minimum time period will be 1 month for this one. So for this, you can write to us in private so that we can discuss on the price. So that's the idea, that we are going to actually use this program and make it available for public. Okay, and also perhaps I should remind you that we have been actually doing this for years. It's always possible to give a key turn project-based approach. So you can we can get the project all together, make all the simulations, and prepare the report and give a movement simulation, or if you wish, traction power simulation report for you. That's always also possible option. Okay. Süleyman, do you have anything to add?
No, thank you very much, Hocam. I believe you explained. Yeah.
Okay, so that's about the registration. It's back to you, Serhat.
Thank you, Professor. To notice again, the application is in the SaaS environment, so you need to buy SaaS application. Moreover, we provide a trial for not just for customers, we provide a trial for students, academicians, researchers, and corporates. Also, we are going to collect the trial requests a couple of weeks, so we will come back to you at least 3 weeks later, we think. And to remind you, this is important, please use official mail addresses when you apply for registration. Otherwise, your application will not be responded. If you have further questions, I can take them. Otherwise, I think we have finished the presentation.
Okay, so thanks all the attendees for giving their precious time for us, and we hope to meet you in another presentation. Before closing, however, I'd like to share a very short survey. So if you can kindly answer the questions, that will be very valuable for us as a feedback in our future presentations.
Taspi, your voice is open, please.
Hello, can you hear me?
Yeah.
Sure.
Thank you for presentation. Actually, I late attend this. I forget my schedule is not prepared to this. My question, actually, I interested for simulation program and simulation report. I worked for 4 years for substation system at the site. Actually, I interested before I mail actually Süleyman Bey, I think so. Anyway, this simulation presentation, any record somebody take, or maybe can we watch again possible?
Yeah, we plan to share the presentation. Please follow our LinkedIn account or our site. We plan to share all there.
Okay, I understand somebody sent for record. Am I right? This presentation.
Yes, we will be actually having the record and then publish it. So we will let you know. Okay.
Oh, okay. Thank you so much.
You're welcome. Okay, I believe our poll is also finished. So I'd like to thank you all again. It seems that the responses are quite good. So thank you once again for attending, and hope to see you in another Hi-Sim event.
Thank you all.
Thank you very much for your attendance.
Bye now.